everybody. Today we're going to be talking about lesson 62, changing improper fractions to whole or mixed numbers. So first let's take a look at an improper fraction. An improper fraction is whenever your numerator is larger than your denominator. Okay, so when this is bigger than this, your denominator, you have an improper fraction. So we want to change that to a mixed number. A mixed number is just like it sounds. It's mixed up. It's when you have a whole number and a fraction, any fraction, as long as it's not an improper fraction. Okay, so I have a mixture of whole numbers and fractions. So let's go ahead and take a look at example 1. Separate 8/3 into fractions equal to 1 plus a proper fraction. Then write the result as a mixed number. Now there are a few ways to do this. I'm going to demonstrate each way and then you can pick the way that works best for you. So the first way, and you always write the original problem, I'm trying to separate 8/3. So I'm going to start by drawing a picture. Okay, so here's my first pie, and all 3 pieces of my pie are filled in. I have 3/3 here. 3/3 is also equal to 1 whole. Okay, so if I subtract 3/3 from my 8/3, I'm left with 5/3. Well, 5/3 is still an improper fraction, so I'm going to draw another pie and divide it into thirds and all 3 of these. So I have 3/3 here, which is also equal to 1. So here I have 3/3 and 3/3, which is equivalent to 6/3. I'm trying to get to 8/3. So I'm going to have one more pie. But this time, since I'm trying to get to 8, I already have 1, 2, 3, 4, 5, 6. So here's 7, and here's my 8/3. This pie only has 2/3 filled in. So if I was to now add these together, I would take my 1 whole plus my 1 whole plus my 2/3, and I would equal 2 and 2/3. So this way is doing it drawing pictures. I could also subtract. I have 8/3. I know that a whole is 3/3, so I subtract 3/3, which is equal to 1, and I get 5/3. Well, this is still an improper fraction, so I'm going to subtract 3/3 again, which is also equivalent to 1, and now I'm left with 2/3. Here's my proper fraction. 2/3. That's a really bad 2. And now I can add these together, and I equal 2 and 2/3. Here's the other way. 8/3 is another way to write a division problem. So if I rewrite it as 8 divided by 3, 3 goes into 8 twice. 2 times 3 is 6. I subtract. I have nothing to bring down, so I have a remainder of 2, but instead of writing a remainder, I write it as my numerator. My divisor, 3, becomes my denominator, and I have 2 and 2/3. This may be the fastest way, but it also isn't as visual to understand really what you're doing. Okay, so 2 and 2/3 is my answer. Let's go on to example 2. The chef baked 2 casseroles. At the end of the day, 3/5 of one casserole and 4/5 of the other casserole remained. Altogether, how many casseroles remained? I'm going to start by drawing a picture. Okay, I'm going to have a rectangular casserole. And each one is divided into fifths. One, two. Okay, really bad fifths. Let's see if I can make this a little bit more even. So at the end of the day, 3/5 of my first casserole, 1, 2, 3, and 4/5 of the other one remained. Must not have been a very popular day for casserole. How much remained? So I have 3/5 and 4/5. Oh. Fifths. There we go. Okay, so I'm going to add these up. Okay, we're going to have, let's put it down here. Remember, when you are adding, your denominator must be the same, and you only add the numerators. So my denominator is the same. It's going to be a 5. My numerator then is going to be 3 plus 4, which is 7. So 7/5 of the casseroles remained. However, this is an improper fraction, so we need to convert it. So I'm going to divide 7 divided by 5. 5 goes into 7 once. 1 times 5 is 5. We subtract. The 2 becomes my numerator. The divisor 5 becomes my denominator. And I have 1 2/5 casseroles left. Notice I said casseroles, plural, because I have more than one casserole. Even though that second one is only a fraction, it's still more than one. Okay, let's go into example 3. A 3-person crew worked for 2.5 hours to repair a broken water line. The customer will be billed for how many hours of work? Okay, we are not multiplying fractions yet, so you must do this kind of problem doing addition. So let's take a look at it. 3 people are each working for 2.5 hours. So I'm going to have 2.5 plus 2.5 plus 2.5. I'm going to start by adding my fractions because we always add right to left. My denominator is a 2 in each one, so I can add those and have a denominator of 2. But then I have 1, 2, 3. So I have 3 halves. We're going to leave that alone for right now. And now I add my wholes, 2, 4, 6. So the customer will be billed for 6 3/2 hours. But this 3/2 is an improper fraction, so we're going to convert it. So 3 divided by 2. 2 goes into 3 once. 1 times 2 is 2. 1 becomes my numerator, and the divisor 2 becomes my denominator. So I've just converted this 3/2 into the mixed number 1.5. But now I need to add it to this whole number 6 again. So now I have 6 plus 1.5, and this is going to equal, put it over here, 1/2, and 6 plus 1 is 7. So the customer will be billed for 7.5 hours. This is a multi-step process. You need to find the total number of hours, convert your improper fraction to a mixed number, and then add that mixed number back to the whole number that you got when you added your wholes. Okay, off to your lesson practice, and I will see you in the morning.